we're going to pick up right where we left off last lesson. So if you're just joining us, go ahead and run all the previous cells in this exercise notebook. Now that we've created 2 new features, we want to evaluate those features to see if they might be providing any new value to the model for distinguishing spam from non-spam. As I mentioned at the end of the previous lesson, we'll use overlaid histograms to look at the value of these created features. So we're going to import pyplot from matplotlib, and we're going to import numpy and store it as np. And then we're going to tell Python to print out matplotlib inline right in our notebook. So the function call to build these histograms is pyplot.hist. So basically we're going to build 2 histograms. The first is going to look at the distribution of our body length for spam, and then the second one is going to look at the distribution of body length for non-spam. And that's how we're going to use these histograms to see if this new created feature is helpful for distinguishing spam from non-spam. So the first parameter that we have to pass in is the thing that we actually want to plot. So that's body len. But what we actually want to do for this first one is we want to filter that data frame to only include rows where the label is spam. So we do that by saying data bracket label equal spam. So filter that data frame down to rows that are only spam, and then it'll look at the body length column for those rows. The next thing we have to pass in is the bins for our histogram. We're going to define that in our own way. So the way that we'll do that is we'll use numpy's linspace function. And what we're going to pass in is the starting point, which is going to be 0, and then the maximum. And for our case, for body length, we'll say it won't go any higher than 200. Then we tell it how many cut points we want in there. And we'll just say 40. So this will return an array with 40 evenly spaced numbers between 0 and 200. And then these will basically be used as the cut points and determine where our bins are placed. So we'll use the same bins for both histograms. Just makes it easier to see the differences. The next parameter we'll pass in is the alpha parameter. And this just tells it how dark we want the shading of this histogram to be. We'll use 0.5. Then we pass in normed equal true, and this will normalize our plots to the same scale. So this is helpful because there's a lot more ham, for instance, in this data set than spam. So if we don't normalize, it'll just be the count. So the ham histogram will dwarf the spam histogram, and it'll be really difficult to tell the differences here. So this normed one just puts them on the same scale. Then lastly, we'll tell it what we want the label to be. We want the label to be spam for this one. And that'll be for our legend that we'll add in just a second. So let's go ahead and copy this line down to the second line, and we can just change the pieces that we need to change. So we'll change spam to ham, and then we'll just change the label to ham. And now that we've passed in labels, we can create a legend. We create the legend by doing pyplot.legend, and then all we have to do is tell it where we want it on our plot. So I'll say, let's put it into the upper left. And then we do pyplot.show. What that does is it takes this object that's been created and actually prints it out in our notebook. So let's run this import statement, and then we'll run our plot. Wow, so you can see that body length is very different for ham versus spam. So spam text messages seem to be quite a bit longer than regular text messages. So it appears that this extra feature could be really helpful for the model to distinguish ham from spam. So if we didn't create this feature, the model may not have necessarily picked up on this difference. Now let's evaluate our punctuation percentage feature. So we can just copy all of our code down here. We need to change the bins because the scale is different than it was for body length. So this is on a percentage scale. So let's make the upper bound 50. So that's saying, I'm guessing none of the text messages have greater than 50% punctuation. But we'll still leave it 40 bins. So again, this will create an array from 0 to 50 with 40 evenly spaced numbers. So now we need to change this from body length to punct percent. So this just tells us, again, we're doing the same filter so that it only selects the rows where the label is spam, and then it looks at the punctuation percentage column. Then we want to do the same thing right here for the column that is selecting the rows with label equal to ham. And then we'll just change the legend. We're going to put it in the upper right this time. And then we'll run that. And now you can see there's not nearly as much of a difference in punctuation used. You can see that spam might be a little bit more concentrated here on the left, whereas ham tends to have more of a tail over to the right-hand side. However, it's pretty clear which one of these new features is likely to help out the model the most. So, in terms of our original hypotheses, our hypothesis that spam messages tend to be longer than non-spam messages seems to be correct based on this evaluation, and this feature is likely to provide some value to the model. However, our hypothesis that ham messages contain less punctuation than spam doesn't appear to be accurate, and it isn't quite clear whether this feature will provide value to the model. Now, in cases like this, where there is some separation between the distributions, typically we'll err on the side of leaving this feature in the model just to see what kind of value the model itself may be able to extract out of it. So this is an example of how you might evaluate whether some newly created features will be useful to the model.